Spooky Island. This is our robot, and so I'm Lena, I'm Candace.
Dave.
And I'm Reese.
So basically our design philosophy for this project was kind of a slow and steady wins the race type of thing. We saw that a lot of other teams had robots that actuated super quickly and went out and did every task as fast as possible, and we decided we didn't want to do that. We wanted to be the last ones so that when we drive in, everybody else's mechanisms have already actuated and we can just counter all of them all at once. So basically, like, if they had thrown their ghost into our section, we would come in after they had already done that and push them all out. So the part of the robot that I designed was this doll arm piece, and basically it works with a pneumatic actuator and a solenoid to drop this entire jig into the center of the robot that holds the doll. The jig is adjustable so that it fits the dolls of any height, and yeah, so basically we're not detecting the sunroof of the Mystery Machine at all. How it works is the solenoid will just contract and the whole jig will rest on top of the Mystery Machine so that when the hole comes around, it'll just fall straight in. So one thing that was very unique about our design and our plan was we kind of had a plan B. A lot of teams were just doing the same thing every time and hoping it worked, and we decided that if we saw someone that was trying to block the center or something like that, we're just going to unplug the solenoid that drops the doll so that we get our 5 points and we're good. So, yeah.
So as you probably saw during the competition, there were two major techniques to getting to the center. A lot of teams glided in on cabinet gliders, having a stationary robot on the base, and then other teams would drive to the center. So just a design choice that we made was we wanted to drive to the center. The reason for this is it put us in the middle of all the actions, so we were closest to the ghost, closest to the center, that sort of thing. So as such, we had a drivetrain. The gears were water jetted with tap screws in the side. We would crank those suckers down and they wouldn't come loose. We had a lot of issues with stripping plastic and DF gears, so we just decided to go with metal. We also had a metal axle with screw taps on the side for the wheels, and then rubber foam texture on the wheels to increase the grip strength on the track.
So the next task that we completed was the ghost removal. There's two wide wings on each side, actuated by a motor in the back on the top. And there's a string between the motor and the inside of each arm. So as the motor intertwines, it pulls the string tighter and the arms extend. And the goal of that was to have the arms extended at an early time frame so that as we were driving to the middle, we would sweep all the ghosts out of the zone.
The final task was the treat retrieval, and in order to do so, our team designed an L-shaped hook that would move in a radial motion and grab the treats back to the center. Our design utilized a pneumatic piston that pushed a rack forward and rotated the gears attached to the arms. Our first iteration used mousetraps, so we decided to move forward without the mousetraps because these mousetraps were placed underneath the robot and were hard to set and easy to accidentally trigger when we flip the robot back over.
The last section was the code flow. So as you can see in the bottom right, first we would continually check if the banana was true, the banana plugs, and then next we would drive. The distance from the center was determined to be 7.35 centimeters during testing. After we were done driving, we would commence all the other actions. You can see them more in detail on the poster board. At the very end, once all actions were completed, we would kill the Arduino with an exit 0 function. That way we ensured that we were not going to move afterwards. One issue with the code was that sometimes if we didn't make it to the center, the code never actually finished. And it never ended, and punched a judge once.
The last section is the expected performance. We're expecting about 13 points on average, 5 of which come from the treats, between getting the treats on Scooby's face or mouth, and then the other 8 points comes from the doll drop, factoring in whether or not we trigger the solenoid and drop the doll into the sunroof or not.
Any questions?